materials and how we can actually make them stronger and tougher. And I use like additive manufacturing of composites, metals, those kind of things. And I also use like artificial intelligence and machine learning to discover new type of composites towards electric vehicles and other type of battery systems. So it's a complex material that I am trying to develop. And our department is small relatively, but I think that's a good thing because why do you need a big department? And all of our research faculty is actually research heavy, so they do significant research. I would say per faculty research expenditure is it's probably the highest, if not the highest, in the College of Engineering. So we do have a lot of research projects for students. It's our curriculum is also relatively new, so we are upgrading the curriculum to have more like programming, modeling, and also AI machine learning type of data science courses. And another point I would suggest checking, because in my mind all of you guys should really check the data yourself and understand how the data is really made, and then make your own decisions. And if you check US labor statistics, for example, it will show you which states and which cities or regions in those states are hiring the what type of engineers or what type of fields. So San Jose area is the #1 hire in United States for materials engineers. So that means there is always a position and that's missing. And as we are a small program, the other programs in Stanford, Berkeley, we only compete with them, and they are also very small. So you can imagine we don't really generate quite a bit of materials engineers in the area. So in my mind, materials is relatively easy to find job discipline in this area. Relative to let's say mechanical engineering or larger programs, electrical engineering, they also find jobs, but it is actually too competitive generally, or in my opinion. And another one final thing, if you also check US labor statistics, it's a little bit interesting website, maybe hard to find the things you want, but if you check it, you will see materials engineers are also one of the highest paid in the nation in the Bay Area. And it's almost nearly as high as some of the electrical engineers. And if you understand computers, some materials engineers are actually doing heavy computational work. One of my friends was like that. And they also get hired under computer engineering ads. That means your salary is going to bump up to like software computer engineering salaries. I don't know. It is the case in my mind. I don't know if I say too much, or any questions from any of you. August, Anna, David, and I don't know who CC is, but welcome all.
Yeah, thanks for that background. That was actually pretty enlightening. The only kind of experience I have with materials engineering thus far is the intro class that I've taken. And my buddy is a materials science master out of Davis. So I kind of have what he's told me and what he does for work, which he works with batteries as well, which has been kind of fascinating for me. I'm mostly into aircraft, but moving everything towards electricity is interesting. So I appreciate that background.
Yeah, very good point. And it's good to see that, you have an insider friend who's giving some more information. Materials is generally less known, but it is, what I would say, our master's program is a little bit larger, for example. The reason is, or relative to the undergraduate, the reason is students get their degrees in mechanical, electrical, or other disciplines, and then they realize its materials is very important, and they keep testing and quality. So they came back for master's degrees. But I don't like it because you can start materials and then push the current status quo. What I'm saying is one part of my research is on structural batteries. So carbon fiber composites, right? Which are strong and tough. So we are basically trying to make those carbon fiber composites also act as like a battery. So I had one project which got rejected from NASA, but that was on electrical vertical takeoff landing systems. So basically air taxis. How can we make them lighter, stronger, tougher? Plus we make the structure of the whole chassis of the structure. We change also it into a battery that can not only hold strength or hold forces and stuff, but also provide energy. So in my mind, materials is always the pushing, enabling technology. Imagine a diesel engine, like 150 years, it's the same engine, but if you have better and better materials, like if you have a ceramic engine, for example, you will beat the industry and you might actually increase the fuel efficiency. So you might actually even compete with electric cars using regular combustion engines, but those require materials innovation. Anyway, some extra information. Ian, welcome. Any other questions? Anything I can help with? I am also the advisor of the materials engineering, student advisor. So I will handle you guys in terms of, which classes, courses you can take if you're interested in coming to our department. And also, I am the advisor of the two materials clubs. One is Material Advantage. The other is Society of Plastic Engineers. And I also got the Best Advisor Award in like 2019 out of 450 advisors. So to give an example, we not only do things in research teaching, but also, help students, do their projects or whatever they want to do, and then help them. All right, any other questions? Fong. Do I say it correctly? Welcome.
Yeah, I have another question if nobody else has one first. So I was just hearing more about the 4+1 program for getting your master's in 1 year. And I am a transfer student, so it wouldn't be the 4, but you were talking about how people come back often for a master's in materials science. Is that 1 year master's program only available if you already majored in that same field, or could you say major in a field like, I don't know, aerospace engineering or computer engineering, whatever, and then go get your tack on 1 year master's in a different field such as materials?
Yeah, that won't work.
I see.
The system is not set up like that. The reason is, when you switch from another major, we actually request whoever is coming to take 4 more courses. So it's like a preparation towards materials masters. Those are undergraduate courses, but main courses mainly. So if you take those, then you can switch to start your master's. So if you're switching from aerospace or anything, it'll be a little bit problematic. But I suggest actually, my biggest suggestion for 4+1, and materials actually the first one which got approved because we really push for you guys. And that's again, one of the benefits of being a smaller department. We can act very quickly. But industry comes back because the money you pay to the masters, it's not that much, but the salary bump you get, it kind of offsets it in a couple of years. So the amount you pay extra to get your masters from San Jose State, it's actually really valuable in my mind compared to just BS. And I guess that's also the value. And then, on top, other people come to our program because they realize, it's heavily materials research or, material testing, some kind of materials related work is done. And that's common. Did I answer your question?
You did. Thank you. I appreciate that.
So Anna has a question. Do the companies that look for material engineers in Sjsu often local, national, or international? We have all. you know, San Jose area is very interesting. There is around like 6,600 different companies in the area. So you can just walk, you know, some of the companies we can just walk. I'm near downtown actually. So just walking distance, tons of companies you can work on. But also, you know, these companies are, you know, super local, some of them. There are like 60 different battery startups, for example, just for batteries. They always request some internship, things like that, so you guys can get in there. But there are also other larger, like Lockheed Martin always gets our students. Even Facebook has our students, you know, they make these VR goggles and headsets, right? There is a lot of materials problem there. So we do have all. All right, another question. Do students feel they are ready to work with BS, or do they prefer? I don't really get the question, Anna, but you know, students are okay, you know, doing BS or masters. It doesn't really, I don't see much of a big difference. But if you come here, I suggest, you know, if you can, just use the 4+1 program to get your master's in a year, because some of your senior courses and stuff will be counted towards your master's. And then last year, 5th year, if you can finish your project or thesis, then you get your master's. So I think that's a very good deal. It also opens up PhD and other type of work, as I do a little bit, you know, hardcore research here. One of my students got into Arizona State as a PhD in the PhD program. Some other students who finish their BS here go to Berkeley, Stanford for their masters. I haven't seen any PhD yet. But those are also other options for students. And if you have any other questions, let me know, or if I didn't answer your question. Alexandra, welcome. All right, any other questions? If you're interested in metal additive manufacturing, I am a big additive manufacturing guy here, and we also have like a metal additive manufacturing printer, which is made out of lasers. I mean, it uses basically lasers to make materials, different type of materials. So that is kind of growing. Yeah, as I said, batteries are here nicely. We have Dr. Sjsu here, Santosh with us. He does purely computational work, more like electronic materials, how to make batteries, solar cells better, or nuclear resistant materials. Those kind of research are being done. All right, other questions? Let me see if I can show you laser welding. You guys see this? This is one of our labs, basically. And this is a metal additive manufacturing system that I got the funding from National Science Foundation. So the whole system is about $350,000 with the discount. And what happens is you can actually 3D print like titanium, currently what we are printing. And then you can also print other type of shapes and structures. It's a very interesting and cool research at this point. And you see in this region, there is lasers are playing and then doing something. So I'll try to share the video now so that you will see it. There is like a powder that is being laid. That's a titanium powder. And then you will see a laser just passing through some regions to melt and solidify. And then that way you get your different type of shapes basically. So now the material is being laid down. These were some kind of interesting shapes that we were printing. I'll show you later. But then you should see the laser going through. This is slow-mo, so it's very fast process actually. Yeah, there is like a very tiny beam laser that is actually melting and solidifying certain regions that we defined in a CAD model. But it's super cool to see this. Some of these parts are other metals that are coming up. Any other questions?
Oscar, there's some questions in the chat.
Sorry. Yeah, the classes were not really impacted. Yeah, we did really fine. Unless there is like, we did even have like access to the lab, so that wasn't a big problem. And the senior design projects can be very different. It can be, it depends on what you want to do. One student project I have currently is, if you have like an injury during like a battle, they are actually making like a, I forgot what it is called, but it is basically a system which stops the blood from flowing with using some pumps. But what we are doing is we are 3D printing some of the systems and then try to make them much more flexible for combat. Other projects I worked are composites and things like that. So it basically has all the, many different type of stuff basically. Metal additive manufacturing, if they want to work with me, if they want to work with Santosh, it's probably computational work. You try to understand how the diffusion is going through in materials. That's I guess the whole thing. Any other questions? Santosh, are you here?
There's another question in the chat. It says, what does the senior design project involve?
Yeah, I just answered that. So it's basically very mixed, any type of design or things like things that you like. And if there is a faculty who wants to work with you, then that would be fine actually. So that's not a big problem.
This seems like a pretty small group, as I kind of expected, one of the smaller majors in terms of engineering. Would you say it's probably easier at any given time to get to know your professors a little bit more and kind of
it's nothing, you know, you can email us anytime you want, and you know, I tend to answer super quick, and we can definitely meet, talk. Research meetings we do weekly.
great? Yeah, I mean, it definitely seems much less crowded, I should say.
Mhm. All right, Santosh, are you here? I gotta take like a 5-minute break, if that's okay. All right, can I see you guys in 5? It seems like Santosh is not here. Okay, sorry. Sorry. All right. So question is, what type of companies we can get in, right? All right. So you see all these things, you know, this Burj Khalifa, these are some of the 3D printed scaffolds, 3D printed building, car. And you see, you can work in any company. So this is the answer. Google X, you see they have a project wing. It's basically a very large plane supposed to provide internet, I guess. And then Amazon's drones. Facebook also has this, you know, large composite drone. And all of these require materials development, testing. Anything you make new requires testing, and that testing is materials testing most of the time. Tesla, you see batteries. It's basically, you know, our work. One of the biggest things related to materials is energy, whether it is wind turbines, nuclear materials, solar cells or batteries. It's materials problem. Yeah, so Apple, Google, Samsung, Facebook, Intel, Tesla, all these Applied Materials is a pretty large company. Transportation work, any kind of manufacturing work, you know, all of these doable. Here is another example, jet turbine engines. You know, one reason why you get actually cheaper plane tickets is due to the materials improvement. Biomedical companies, there are a lot of biomedical companies, they all hire materials engineers. There are also specific ones like failure analysis companies. Most of are also, you know, materials, mechanics background, fracture. So let's stop share. All right, the last question, is it to me or to you, all of you? Has everyone here been set on material science for a while, or some of you just investigating to see what's about as well?
Yeah, I was just kind of asking the room.
Yeah, not many people, students don't really realize the materials, but yeah, as I said, in my mind, it's very good because it's also very flexible. So interdisciplinary aspect of material sciences, I think I like it most. The reason is if you want to switch to any other discipline or anything you want to do later in the life, you will have like a very broad background. And the future is really complex. So, you know, having a broad background is actually important. And materials are not going to disappear. All the companies are trying to do something new, and there will be always jobs, and especially for a smaller community, right? So mechanical engineers, maybe some other type of fields, you know, there will be a lot of people out there, but for materials, the importance is getting higher and higher every day. With new products, anything you see new is probably going through some kind of materials work. And that makes our discipline valuable, basically. All right, did I answer all your questions, or are there anything else I can answer? So basically, overall, it's up to you, right? Whichever discipline you're getting in, you do the work, you spend the hours. Do not really waste a lot of time. Focus on what you want to get, and then push through it. If you do that, your job will be there for sure, especially in the Bay Area. So you coming here and then asking questions about companies, it's a little bit off for me because, there will always be companies here. And I'm sure, if you spend enough time in terms of searching, doing the job, getting okay grades, then you'll be able to get a job. I mean, for sure, unless there's a big problem. There is another big problem. All right, anything else I can answer or any comments, questions? You can use the chat too.
I appreciate your information today. It was actually very helpful considering how little information I had about materials going into this. If I had any more questions moving forward as my current term kind of winds down, would I be able to reach out to you or somebody else about materials? Oh, fantastic.
Yeah, just you can directly email me any questions you want. If I can't answer, I'll try to direct you to the people who might help.
Thank you. I really appreciate that.
Of course, no problem. I mean, it's our job. But a bigger, maybe overall larger view of advice is, just think about what you really enjoy, what you think you can spend time on, and then try to think about, where the universe is, our world is going, and then think about something meaningful in the next 5-10 years at least, because things are changing much faster than previous times. So you gotta be agile. You have to basically have a diverse background. But if you find the things that you like, you're gonna spend more time without getting bored. That means more time spent on a topic means you will learn more than others. Learning more than others, you'll be valuable to other companies, especially if you also have like critical thinking, those kind of creative skills too. So if you find the things you like and then you enjoy, reading those, going through, then you will have a competitive edge. That's, I guess, most important. I had no idea what's going on with materials when I first, got into my BS materials, but then I realized I really like it because it's complex topic that satisfies my urges. That's how I ended up doing it. But, in my mind, if you guys can figure out what is important, what makes most sense in the near future, how you can capitalize that, I think that will be more valuable. As I said, check the US labor statistics, find the statistics on your own and then see, which type of engineers or, fields are doing what and how you can go for those type of careers. Did it make sense?
Yeah, absolutely. Thank you.
All right, I'll be here for a while, but no questions. You guys don't have to, wait here with me. And as I said, just shoot me an email if you guys have any other questions, or just let me know if you want me to answer anything now too. That's fine. So where are you at, Ian, currently? Or Spencer, any of you guys, where are you right now?
Currently, I'm in Portland, Oregon, but I'm from Pleasanton.
I see. It's a nice place too, Oregon, Portland especially.
Yeah, it's not really my thing. It was a brutal winter. I definitely missed the California winter, but it's a lot of rain. It's a
Yeah,
lot
that
of
is
rain.
true. Yeah, if you go through that seasons.
Yeah, the spring is coming in, which is really nice, but I mean, it kind of wasn't worth how cold and wet it was for so long. But you
Mhm.
know,
So
I'll be
hopefully you
back
will come
soon.
back.
Yeah, absolutely.
All right, if no questions, we can end the session, I guess. 35. Yeah, you guys don't have to stay here, as I said.
Yeah, I had one more kind of general question. As I'm looking over kind of what it takes to transfer in for material science, it looks pretty much the same as any other engineering discipline. It looks kind of the same as mechanical engineering. I can't see anything that stands out as kind of specific that you would need to take in community college to.
I don't really know, but maybe chemistries if you haven't taken, because chemistry is generally the other, like material science, as I said, the most interdisciplinary work we have. So it also includes Chem 1A, Chem 1B, I guess, whatever those in the community colleges.
Right.
So that might be, that's the only thing that comes to my mind. But other than that, you take materials courses, things like that, that those could pass through.
Yeah. Okay. Not OChem though. Is OChem required?
OChem is not required for us, but
Gotcha.
if it's a good OChem, there might be a way to accept it as like a technical elective. So you might get rid of 3 units
Oh, okay.
with
All right.
like a transfer credit possibility for that. But they all go through all these, petitions. You show your, transcript. I mean, syllabus for that course, and then it goes to the department here. Let's say chemistry department, and then they check, and then they basically approve if it is comparable to the OChem we have. If they say yes, then we accept it as like a technical elective. That's another end of the equation.
Gotcha. Cool. All right. Well, thanks again for the information. I appreciate it. If I have any other questions, I'll make sure to reach out.
Answer, yeah, thank you very much for the questions, and just let me know if you have any questions.
Sure. Have a good day.
You too, take care. Florence, are you there?
Yes, I'm here.
Okay. Can we end the session or not?
Yes, absolutely, we can.
Was
Thank
it
you so
okay?
much. Uh-huh.
Was
It
it
was.
okay?
Yes, it was. It was great.
Okay, yeah, thank you.
Okay,
Bye-bye.
have a good day.
You too, bye-bye.